Hello everyone, today we'll be talking about proofs with perpendicular lines, and in this first video we're going to be looking about finding the distance from a point to the line. So the distance from a point to the line is just going to be the length of the perpendicular segment from the point to the line. In other words, the shortest distance from a point to the line is the perpendicular segment. And so we see that picture here. So if I was finding the distance from point A to the line K, that distance would be the length of AB. So let's look at some examples. So for number one, I want to find the distance from point A to line BD. So I have point A right here, and I want to find the distance from that to line BD. So I have three different segments that are connecting A to this line, but I know from my definition up here that the length is the perpendicular segment from the point to the line. And so that perpendicular segment I see is this AC. Here, let me draw that with my purple. And I know that is the perpendicular segment because of this red box right here that's indicating that this is a right angle. Because remember, perpendicular just means that the lines intersect at a right angle or 90 degrees. So that means I need to find the distance of A to C. And so I'm just going to rewrite what A and C are. So A is the point -3, 3. And C is the point 1, -1. And so if you recall, to find the length or the distance, I need to use the distance formula. So this goes back to our first unit. And that distance formula is x2 minus x1 squared plus y2 minus y1 squared. So my first step is I want to label what my x1, y1 are, my x2 and y2 are. I'm going to go ahead and have my point A be my x1, y1, so that means that -3 is x1, 3 is y1, 1 is x2, and then -1 is y2. And now I want to go ahead and plug those values in. So x2 I have as 1, minus a -3, so I'm subtracting a -3, which really means I'm just adding 3. Whenever I subtract a negative, that really becomes a positive. And then my y2 is -1 minus y1, which is 3. Okay, so 1 plus 3, I get 4 squared, plus -1 minus 3, I get -4 squared. 4 squared, I get 16. -4 squared, I get 16. Which is equal to the square root of 32. And now for your homework, I am going to have you write these in simplified radical form. And so if you want a review of how to simplify radicals, you can go back to that first unit. I think it's one of the first lessons. But if you remember, I can split this radical into two different radicals, multiplying them. And my goal is to find that perfect square. I know 16 is a perfect square and it goes into 32, so I can really go ahead and split this as square root of 16 times square root of 2. The square root of 16 is 4, so I get 4 square root of 2 as my answer. Okay, let's try this second example. So I want to find the distance from point E to FH, this line. And so I know that my distance is going to be my perpendicular segment, so that means I want to find the length of EG. So E is -4, -3. G is 1, 2. Label my x1, y1, x2, y2. So that means that EG is equal to x2 minus x1 squared, like we see over in this first example. So that's 1 minus negative 4, which is really just 1 plus 4 squared, plus 2 minus negative 3. Again, when you're subtracting a negative, that becomes a positive, so that's going to be really 2 plus 3 squared. 1 plus 4, I get 5 squared, plus 2 plus 3 is, again, 5 squared. So I have 25 plus 25, which is equal to the square root of 50. Now I'm going to go ahead and re-show that other way we learned how to simplify radicals with that factor tree. So I'm just going to split these into these prime factors. So I know 2 goes to 50, so that's 2 and 25. And then 25 is 5 and 5. Remember that only pairs can come out, so I have a pair of 5s, so that means that this is going to be 5, and then all that's left over is a 2. So the answer here is 5 square root of 2.